Let us talk about the Cauchy-Riemann equations. Now, this is connected with complex functions. So those will be functions that involve complex numbers, right? As the variables, complex variables. Now, in order for a complex number to be analytic, remember now, it must be continuous. That means you shouldn't have anywhere where the complex number is such that you're trying to divide by 0 or something like that, right? You mustn't have any piecewise function. It must be continuous. You must be able to differentiate it, right? E-I-A-B-L-E. It must be differentiable. And then, of course, it must follow. It must conform to the Cauchy-Riemann equations. It must satisfy the Cauchy-Riemann equations, right? All right. Now, the Cauchy-Riemann equations. Let's not look at it directly yet. Well, you can find it all around on the internet, in books and so on. But, or I should say them, because there's more than one equations, right? Let's see how we can develop the Cauchy-Riemann equations. Suppose you have a complex function. Say W is equal to U plus JV, where U and V, right, are variables. And let's say you have another one, Z is equal to X plus JY, right? Now, the fact that you have W is equal to U plus JV, it means a change in W can be represented by a change in U plus J times a change in V, right? And a change in Z can be represented by a change in X plus J times a change in Y. Now, remember that J sometimes is also represented by I, right? It's the same thing. You could use J or you could use I. But for the same problem, you know, be consistent. If you're using J, just use J for the same problem. If you're using I, just use I. Alright? Now, what is dW by dz or dz? Now that would be the limit as a change in z tends to 0 off. Now, let's see what that will give us. Remember, when you are looking at differentiation from first principle, alright? If you have W here, then right here would be W plus a change in W, right? And then this now would be f of W plus the change in W, and this, say you have W here, say W is here. This would be f of w, alright? And the gradient of this chord would be the rise, that means f of w plus change in w minus f of w over the run, that means w plus change in w minus w. You see that? Alright. However, in our case here now, we're finding dw by dz. Let me draw our curve again. Now, here, this is our z-axis, and this is our w-axis. So the rise will be changing w, and the run will be changing z. Alright? Now, this here is z, and this here is z plus a change in z. So this here is w, and this, let me just erase this and replace it with w plus a change in w. Alright? So our rise in this case is w plus a change in w up here minus down here. So minus w. Alright? Over, and then the run would be z plus a change in z minus z. So you see that? Now, that change in w, oh, I didn't write w up here. It's delta w that I should have written here. So let me write it now. I have delta w. Alright, now that change in w by changing z. How do I deal with this now? Limit as delta z tend to 0 off. Alright, so here, this now would be w. Well, this would amount to w minus w is 0. Let's put it as delta w over z minus z is 0. So you have delta z. Alright? Change in w over change in z. So this is the limit as delta z tends to 0 of, what is that change in w? It's change in u. It's like we have up here. Change in u plus j change in v over this one now, that's delta z, that's change in x plus j change in y. Alright? Now you have x and y on the bottom. Remember, with differentiation from first principle, the item, the variable under the bottom of the line, in the denominator, it approaches 0. But now it's two variables we have. At the top, we have a real part, w, and an imaginary part, v. So we have change in w, the real part, and change in v, the imaginary part. Down the bottom, in the denominator, we have change in x, the real part, and change in y, the imaginary part. Now, let us make one change and then the other. This would be have been delta z. I left out z. Z consists of two parts, x and y. Let's make both x and y change, but one at a time. Now, what is the limit? As let's x change first. Changing x tends to 0. Right? If we make 8 changing x, let x tend to 0 of changing u plus j changing v divided by changing x plus j changing y, what would happen? Well, as delta x this or del x this part approaches 0, then what we would have? The limit of that would be delta u plus j, or del u plus j del v. It would be change divided by j del y. So you see what happened there? No. It's a fraction, you know. So we can write it as del u over j del y plus j changing v over j changing y. Remember, that type of curly delta is what I call del, which is representing a change. Alright? Now, how do we deal with this part of things now? Here, what we have is del u over j del y. Now, this part, you don't have much of a problem with it. The j's will cancel. J cancel j, alright? So you just have del v over del y. But how you deal with this part? Oh, guess what? Suppose you multiply both top and bottom by j. What would happen? You have del u over del y, but the del y is multiplied by j. Multiply this by j over j. Now remember what j is. J is the square root of negative 1. So j times j means the square root of negative 1 times the square root of negative 1, which means the same as the square root of negative 1 squared. So what is the square root of negative 1 squared? It is negative 1. You see that? So what we have here is j del u over del y plus del v over del y. But under here, we have del y times negative 1. You see that? So, what would we have here? It would be del v over del y minus j del u over del y. Alright? So, del v by del y minus j del u by del y. So, let us highlight this. Let me put a star beside this. 3 stars. Now, here, let's come back to this. And what we're going to do is let This time let delta y go to 0. So let's just get these things out of the way. I don't want to erase the result that I have here. Alright. In fact, let me move this to one side. I'm going to be using it later on. So now, suppose it is del y that I make approach 0. What would happen? Well, under here, this part would go to 0 at the limit. So we have this divided by del x. You see that? So what is this equal to? I had this before. What is that equal to? Well, that would be del u by del x plus j del v by del x. Alright? Now, here. We have this part of things as well. Del u by del x plus j del v by del x. Now, if both del u by del x plus j del v by del x and the other thing we have here, del v by del y minus j del u by del y. If both of them are to have the same value, whether it is x change first or y change first, then what must happen? They must be equal, right? It is necessary for them to be equal. So they must be equal. They must be equal if they are to have the same value regardless of whether change in x tends to 0 or change in y tends to 0 first. Alright? So what I can write here then is that if they must be equal, then I could change this thing, this and to equal sign. Alright? Now, that means del v by del y minus j del u by del y must be equal to del u by del x plus j del v by del x. Now, you have real part here and imaginary part here. Alright, you can see that. On this side you have the real part and you have the imaginary part. Now suppose we equate real and imaginary parts. Alright? Suppose we equate them. Go to that. We say del u by del x. Del u by del x is equal to del v by del y. Right? And the imaginary part, del v by del x is equal to negative del u by del y. All right. So we have here. Remember that as we approach 0, the del would change to delta now. So we're reapproaching 0. So I should really write these as delta, not del. So this would change to delta. All of these dels. Right? I forgot for a moment that while they're approaching 0, use this curly delta here. But at the limit, as we tend to 0, and all of these would be this other curly delta, well, the curved delta, rather than the curly one. So, what we have here is delta u by delta x equal delta v by delta y. And delta v by delta x equal negative delta u by delta y. Alright? So, looking back, these dels, they really should be delta. Right? All of these dels should be delta. It slipped my mind for a while that as you approach the limit, as you reach the limit, all of these curly delta become the curved delta. Alright? So these over here, they are okay as curly delta. But these should be curved delta. That is after you reach that limit, or well, as you get close to that limit. All right, so here delta u by delta x equal delta v by delta y, and delta v by delta x equal negative delta u by delta y are the Cauchy Riemann equations. All right? Now, try to remember the Cauchy Riemann equations. I'll see you in the next video.